Trigonometry is an essential branch of mathematics that deals with the relationship between the angles and sides of triangles. It plays a vital role not only in solving mathematical problems, but also in understanding and describing the world around us. Trigonometry is important because it helps us measure distances and heights that are difficult to reach directly, such as the height of mountain, the distance of stars, or the slope of a roof. Beyond the classroom, trigonometry has a countless real-life applications. Engineers use it in designing bridges and buildings. Architects apply it to create accurate plans, and pilots and sailors depend on it for navigation. Even in technology, trigonometric principles are used in computers, graphics, sound waves, and satellite systems. With its wide range of uses, trigonometry proves to be a powerful tool that connects mathematics to practical, everyday life. In the first video, we learned how coterminal and reference angle work. These concepts help us identify angles that share the same terminal side and understand how to find the corresponding reference angle, a key step in solving trigonometric equation accurately.
Coterminal angles. Two angles in standard position that have a common terminal side are called coterminal angle. Observe that degree measure of coterminal angles differ by multiples of 360 degrees. So now let's have an example. We have this negative 150 degree. To find the positive and negative coterminal angles, we can add and subtract by 360 degrees of the given degrees. So now we can find the positive coterminal. So negative 150 degrees plus 360 degrees is equal to 210 degrees. While the negative coterminal, negative 150 degrees minus 360 degrees is equal to negative 510 degrees. So we have here the Cartesian plane, this is the positive 150 degrees, while this is the quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So this is the 0, 90, 180, and 270 degrees. So here is the positive 150 degrees, but our given degree is negative 150 degrees. Again, this is 150 degrees, but our given is negative 150 degrees, so it is on the quadrant 3. We can start on the initial side, which is the positive x-axis. So our positive coterminal is starting in the initial side, go through our terminal side. So this is the 210 degrees, which is the positive coterminal. To find the negative coterminal, we can rotate it by clockwise rotation. So we can start here, go through the initial side, and another rotate through the terminal side. So our negative coterminal is 510 degrees. So let's have another example. So we have here given region, which is pi over 3. So, and 360 degrees is equal to 2 pi. So, pi over 3 plus 2 pi, and let's write the common denominator, is equal to pi over 3 plus, so since our denominator is 3, let's multiply 2 pi and 1 by 3. So 2 pi times 3 is equal to 6 pi, and 1 times 3 is equal to 3. So since we have 1 here, 1 pi plus 6 pi is equal to 7 pi. And let's just copy the denominator. For our negative coterminal, let's just do the same process. But let's change the sign, which is subtraction. So pi over 3 minus 2 pi is equal to pi over 3. So the process here is let's multiply both 2 pi and 1 by 3. And our sign is negative. And let's write 6 pi over 3. Now 1 pi minus 6 pi is equal to negative 5 pi. And copy the denominator. And here's our negative coterminal. Now let's graph it. Pi over 2 is equivalent of 60 degrees. So now we can easily find the terminal side. It's on the quadrant 1. So we can now grab the positive coterminal and let's rotate it with counterclockwise. So here our positive coterminal, which is the 7 pi over 3. And to find the negative coterminal, we can rotate clockwise rotation. And our negative coterminal is negative 5 pi over 3. So now let's convert radian to degree. So we have the formula of radian multiplied by 180 degree over pi. So let's have another example, which is what we solved earlier too. So pi over 3 times 180 degree over pi. So now let's just cancel the pi and we have visible one here. 1 times 180 is equal to 180 degree and 3 times 1 is equal to 3. And now 180 degree divided by 3 is equal to 60 degree. That's how we convert radian to degree. Also, that's how we come up the answer that we solved earlier to find the negative and positive coterminal angles. Let's now proceed to converting degree to radian. So we have the formula of degree multiplied by pi over 180 degree. Let's now have another example, which is what we solved earlier, which is 150 degree. So now 150 degree times pi over 180 degree. Let's just cancel the degree and negative 150 times pi is equal to negative 150 pi and copy the denominator. And negative 150 pi divided by 180 is equal to negative 5 pi over 6. So now let's proceed to reference angle. A reference angle is the smallest positive angle between the terminal side of a given angle and the x-axis. It's either positive or negative x-axis. Here's an example. We have positive 150 degree. So it's on the quadrant 2. And here the positive 150 degrees. So since it is on the quadrant 2, we can subtract 150 degrees by 180 degrees. So 180 degrees minus 150 degrees is equal to 30 degrees. So now our reference angle is 30 degrees. So let's have another example, but it is quite complicated. We have here 7 pi over 4. To solve it easily and properly, we can convert pi or radian rather into degrees. So we can easily define the location or the quadrant of our terminal side. So 7 pi over 4 times 180 degrees over pi. Cancel the pi and 7 times 180 degrees is equal to 1260 degrees and copy the denominator. And 1260 degrees divided by 4 is equal to 315 degrees. And 315 degrees is on the quadrant 4. To understand it easily, here's the full rotation, which is the 360 degrees. And another counterclockwise rotation, which is the 315 degrees. So basically, we can subtract 360 and 315 degrees, come out with the answer of 45 degrees. So our reference angle is 45 degrees. So since the given is on the radian, so we are gonna convert the 45 degrees into radian 2. So 45 degrees times pi over 180 degrees. Cancel the degree. 45 times pi is equal to 45 pi over 180. And 45 divided by 180 degrees is equal to 1 pi over 4. So meaning our real reference angle is 1 pi over 4.
The second video focuses on the graph of cosine and cosine functions. We'll discuss the amplitude, period, x scale, phase shift, and vertical shift, as well as their domain and range. This part will help us visualize how trigonometric functions behave and change in different situations. Hello everyone, welcome to my blog. Today we are going to learn how to find exact values of circular function using reference angles 30 degrees, 45 degrees, and 60 degrees for our special angles. So today we're going to introduce the SOHCAHTOA Koshakaw. But before we start, let's recall our trigonometric relationship. So we have here the 30 degrees, 45 degrees, and 60 degrees. Our given is theta is equal to 7 pi over 6. So we're going to translate it into degrees. 7 pi over 6 multiplied by 180 degrees over pi is equal to 210 degrees. So to find our reference angle, 210 degrees minus 180 degrees is equal to 30 degrees rather. So here our graph. So 210 degrees is in the quadrant 3. So our hypotenuse is 1. Our opposite is negative 1/2. And our adjacent is 3, negative square root of 3 over 2 into 110 degrees. So let's find the sixth trigonometric relationship. So first is sine 7 pi over 6 is equal to opposite over hypotenuse, which is the SOH. So negative 1/2 our opposite, and our hypotenuse is 1, so meaning it's simply negative 1/2. So next is the cos. Our cos is the ka, or the adjacent over hypotenuse. So it's negative square root of 3 over 2 over 1 divided by 1. So simply negative square root of 3 over 2. So next is the tangent. Tangent is equivalent to TOA, or meaning the opposite over adjacent. So our opposite is negative 1/2 over the adjacent, which is the negative square root of 3 over 2. Just simply solve it. Cancel out the 2. When we have square root of 1 over negative 1 over square root of 3. So let's multiply it to square root of 3 to cancel out the square root. And our answer is square root of 3 over 3. And it's negative. So let's proceed to our cosecant. Cosecant, also known as the co, or the hypotenuse over opposite. So our hypotenuse is 1, our opposite is 1/2. So meaning is supposedly as the value of cosecant is negative 2. So next is the second, or the sha.
So the hypotenuse over adjacent, and our hypotenuse is 1 and adjacent is negative 2 square root of 3, the reciprocal of cos. So it's basically negative 2 square root of 3, and let's multiply it both by square root of 3 to cancel out the square root. So the answer is negative 2 square root of 3 over 3. And let's proceed to the last is the cotangent or the cow. So adjacent over opposite. So our adjacent is negative square root of 3 over 2, and our opposite is 1/2. So cancel the both negative 2 or in the denominator, so meaning the answer is square root of 3. Example number 1. I identified the amplitude, period, phase shift, vertical shift, and the x scale, then plot one full cycle. So let's proceed to our example number 1. So our example number 1 is y is equal to 4 sin quantity of 2x minus pi plus 2. So now our amplitude is the A, which is the 4. So the graph goes 4 units above and 4 units below the midline. So next is the period. Our formula for period is 2 pi over b, and our b is equal to 2. So meaning 2 pi over 2 is equal to pi. So the period is pi, so 1 full since wave completes in pi units on the x-axis. So let's proceed to phase shift. So 2x minus pi is equal to 2 the quantity of pi minus x minus pi over 2. So because from here, because where we use h is equal to c over b, and b the quantity of x minus h. So from here, it goes to shift into pi over 2 to the right. So the graph shift right by pi over 2. So next is the vertical shift or the midline. So vertical shift is positive 2, y is equal to positive 2. So the midline is y is equal to 2. And next is the x scale. Our x scale is period over 4, and pi is equal to 4 because we'll step by pi over 4 along x to mark the 5 important point of one cycle. So our x, or the start of our midline, is pi over 2. This is where being part of the x scale anyway. So our x sub 1 is the pi over 2 plus pi over 4 is equal to 3 pi over 4. Oh, this is actually 2 pi over 4 rather. So next is the x sub 2 is equal to pi over 2
plus pi over 2 is equal to pi over 4. It's equal to pi rather. That's the half period of the midline. And our x of 3 is pi over 2 plus 3 pi over 4 is equal to pi pi over 4, or the 3/4 minimum. And last is the end of the cycle, which is the x sub 4 pi over 2 plus pi is equal to 3 pi over 2. So let's proceed to our graph. So here our Cartesian plane. Let's just plot the x scale that we solved earlier. The negative side. The vertical. Let's just put the square the pi over 2 rather. So next is our phase shift. Let's just move to the right, which is the pi over 2. So let's just write the vertical. And our next is vertical shift is the positive 2. So next is the graph. So let's start to positive 2, go through 3 pi over 4. This is wrong, wait. Go to no, wait. Go to 3 pi over 4 into the negative 2, which is the minimum, and our maximum is positive 2. So from positive 2, go through 3 pi over 4 and then negative 2 and up to positive 2 again, and to the end of the circle. Let's proceed to our second example. So our given is y is equal to negative 3 cos the quantity of 2x plus pi plus 1. And our amplitude is a, and our a is negative 3, so simply the answer is positive 3, always positive. So let's proceed to our period. Our formula per period is 2 pi over b, and our b is positive 2. So 2 pi over positive 2 is equal to pi, cancel out the 2. So next is the phase shift. So our phase shift is 2x plus pi is equal to 0. So transpose the positive pi into negative pi. So 2x is equal to negative pi. And divide both sides by 2. Cancel out the 2. So x is equal to negative pi over 2. So our vertical shift is just simply the 1. So y is equal to 1, or upward, 1 up. Again, our x scale is pi over 4. So our graph is, let's point the x scale first. Positive x scale. And the negative x scale. And next is the vertical. So let's change the value because there was part of missing, which is the pi over 4. So let's analyze the phase shift, which is the move to the left, the negative side, which is the negative pi over 2. Next is the vertical shift, which is the one up. So let's find some points and do the graph from negative 2 up to the positive vertical scale. That's all for today's video. Bye bye. Thanks for watching. For the final video, we'll apply trigonometric identities to find unknown trigonometric values and solve real-world problems. This section will include 2 example problems and 2 problems, showing how trigonometry is used in practical scenarios and mathematical reasoning. Our given is secant theta is equal to negative 13 over 5, and the angle is located in quadrant 2. So first, secant is the reciprocal of cosine. So let's convert this into cosine to make it easier. So secant theta is equal to 1 over cos theta. And its reciprocal is cos theta is equal to 1 over secant theta. So for us to know what is the cos theta, we can use the formula of cos theta is equal to 1 over secant theta. And let's now put the value of secant theta is equal to negative 13 over 5. So let's just multiply the 1 and the denominator of the negative 13 over 5, which is the 5. So 5 times 1 is equal to negative 5 times 1 is equal to negative 5 over 13. So now let's proceed to sine squared theta plus cos theta, cos squared theta rather, is equal to 1. This is the Pythagorean identities. So now let's substitute the value of the cos theta. Sine theta plus the value of cos theta, cos squared theta is negative 5 over 13 squared is equal to 1. So now sine theta plus, so let's now proceed to square root of negative 5 and over 13, and the square root of negative 5 is 25 and the 13 is 169 and is equal to 1. So let's transpose the 25 over 169 to the right side of the 1. So now sine squared theta is equal to 1 minus, because we will change the sign of the 25 over 169. So now let's change the value of 1 into the denominator of our cos theta for us to know what is the result of the sine theta. So sine squared theta is equal to 169 over 169 minus 25 over 169. And let's just copy the denominator. So sine squared theta rather. So 169 minus 25 is equal to 144. And copy the denominator, 169. And since there's a square root, so let's find the square root of 144 over 169. So let's just cancel the square. So sine theta is equal to 12 over 13. So now, since we have the value of cosine and sine, so we will find the value of the tangent. So tangent is equal to sine theta over cos theta. So let's just put the value of those both data. So our sine is positive 12 over 13, and our cos is negative 5 over 13. So let's just cancel the 13 or the denominator, so we have the answer of negative 12 over 5. So now let's proceed to those 6 trigonometric function, or the values of those 6. So sine squared, cos theta rather, tan theta. So our sine is 12 over 13, and its reciprocal which is the cosecant is the 13 over 12. Now the value of cos theta is negative 5 over 13, and its reciprocal of the secant rather, which is the negative 13 over 5. And our tangent is negative 12 over 5, and its reciprocal of cotangent, which is the value of negative 5 over 12. So using the reciprocal identity and the Pythagorean identity and a quadrant sign, we are be able to complete all 6 trigonometric function correctly. So now let's move on to the next part of the discussion.
Hello guys, Trends here. Since tapos na si Lester in tackling his topic, let us now try solving word problems involving trigonometric identities. So, without further ado, let's do this topic. So, let us start with this problem. So, a firefighter ladder is leaning against a building. The top of the ladder touches the wall 9 meters above the ground. The base of the ladder is 15 meters away from the wall. By knowing what trigonometric identities are, we'll easily answer this question or this problem. So let us try this problem. So, first things first is that you have to know what are the identities in trigonometry, such as the double angle identities, the cofunction identities, the Pythagorean identities, and so on. So we are given 9 meters and 50 meters. That is an helpful information. So these are the identities that can be used throughout the problem. Tangent theta equals opposite over adjacent, cotangent theta equals 1 over tangent, and Pythagorean theorem. So, but hindi Pythagorean identity. So, let us explain here, but hindi siya Pythagorean identity. So now, let us visualize the problem. So, here's our illustration. So, according to the problem, the top of the ladder that touches the wall is 9 meters above the ground. So, initially, it is the height of the wall. And, from the ladder, yung pinaka-base ng ladder is 15 meters away from the wall. And, the height of the ladder is unknown, or which in a right triangle is the hypotenuse. So, let us put values on each leg of a right triangle na to. So, for the opposite side, we have a value of 9 meters. And for the adjacent to our side, we have a 15 meters. And the hypotenuse is unknown. That is the height of the ladder. So, let us now first answer what is the value of cotangent and tangent. So, we know that tangent theta is equals to opposite over adjacent. In the problem, our opposite is 9 and our adjacent is 15. So, we're just going to be simplifying this by simply dividing both sides by 3 since they're both divisible by 3. So our tangent data is equal to 3 over 5. So tangent data is the reciprocal of cotangent, and cotangent is the reciprocal of tangent. So therefore, it is adjacent over opposite. So 15 over 9 is, when simplified, is 5 over 3, which is just reciprocated. So here's the Pythagorean theorem. So as you can see, A is the opposite side and B is the adjacent side, and C is the hypotenuse, which is the longest side of the right triangle. Since we're dealing with a missing angle or a missing leg, which is the hypotenuse, we're going to use the Pythagorean theorem. So in our problem, the opposite side is 10 meters, which is initially the height of the wall. So we're going to be using the a squared b squared equals to c squared formula of the Pythagorean theorem. So 9 squared plus 15 squared equals to c squared. So 9 squared is 81, that's 81, plus 225, which is the 15 squared, equals to c squared. So c squared equals 306. Then square root lang natin, which is about C is equals to 17.49, approximately 17.49. So therefore, the value of tangent theta is 3 over 5 and cotangent theta is 5 over 3. The length of the ladder is 17.49 meters or 17.5 meters. So on to our next problem. The angle of inclination from a point on the ground is 40 feet away to the top of the London's Big Ben is 60 degrees. Find the height of the clock tower to the nearest foot. So let us illustrate or visualize this problem. So according to the problem, yung angle of inclination daw na given is 60 degrees, and the distance from that point to the Big Ben is 40 feet away. So in this problem, we can use the identity tangent equals opposite over adjacent. So in the problem, we are trying to determine the value of or the height of the Big Ben. So the height can be expressed to the variable h, which is going to be our opposite side, and our adjacent is going to be 40. Since we're also given the angle of 60 degrees, we can use it in tangent data. So we're going to use tangent of 60. Tangent 60 is equal to h over 40. So let's solve for h by cross multiplying. Tangent of 60 has an invisible denominator 1. So let us cross multiply it. Tangent of 60 times 40 is 40 tangent of 60 degrees, and h times 1 is h, which gives us h is equal to 40 tangent of 60, whereby if you calculated this using the calculator, you'll get an approximately 69.28 feet, which is the height of the Big Ben. And that's it.